This is lesson 7.2 called Substitution Method. The goal for this lesson is I can solve a system of linear equations using the substitution method. How convenient is that? So there's some drawbacks to graphing method. Like sometimes it's not feasible to use the graphing method to solve a system of equations. In fact, it isn't feasible most of the time. What happens is you end up with lines that cross that are not integer values, so you can't tell what the actual solution is. If it's some fractional value or decimal value, you're not going to get it right by graphing. Sometimes the graph has to be so large that it's just inconvenient. Like on this one here, you're going to have a graph if you go slope-intercept form of a y-intercept of negative 50. And that's not feasible when the other one's negative 8, and you don't have space to grid that, and you can't go by something other than ones, because then you're not going to be sure of what the answer is without plugging them in and checking to see if you got the right one. So graphing without technology is just inaccurate. So there has to be some other way, right? So we have this method called substitution method. And so what you're going to do is you're going to choose one equation of the two. So you have two equations down here. And you're going to solve it for x or y. That means you're going to get x or y all by itself. But let's assume that we're going to solve for y. Once you solve for y, you'll substitute that expression for y into the other equation in place of y. Then you'll only have x's in your equation, and you can solve the equation. Once you know the value of x, you substitute back in to the other equation, and you're going to get the value of y. So if you look at these two equations, one of them's already solved for y. So I don't have to do step one. That's already done. Now the second part is the substitution step. So you have just found a replacement for y. So y is the full-time teacher in the room, and negative 9x minus 8 is the substitute. So you're simply going to replace y with negative 9x minus 8 in this first equation. That's the substitution step. So it looks like this. Negative 5x plus, but instead of y, I'm going to put in what y is equivalent to, which is negative 9x minus 8. And then I'm going to distribute if I need to, but there's no coefficient here. It's a coefficient of 1, so no distribution, so I can just remove my parentheses like this. Combine like terms. Add 8. Negative 42, I think. Then 3. X is 3. So now I need to, so I just did step 3. I solved the resulting equation for x. Now step 4 is substitute that value for x back into the equation from step 1. So we're going to come right back up here, and we're going to plug 3 in for x. And then that'll tell us the y value when we do the math on this one. So negative 27 minus 8 is negative 35. So there's my y. And now make an ordered pair, right? Step 5. Write, that looks like an 8. Write your answer as an ordered pair. So 3, negative 35. There's our answer. Okay, so let's run back through that again. So we're going to choose one equation and solve it for x or y. Well, in this particular example, equation 2 was already solved for y. Y is by itself. So then I substituted that expression, the expression being negative 9x minus 8, into the other equation, equation 1, for y. And that's where I got this from right here. And we solved that, step 3. We solved it and got x equal 3. Once we knew x, we had to go get partner y, so we went back up here to this y equals equation. We plugged 3 in there for x, and we got negative 35. And the big finished right answer as an ordered pair. Okay? Let's look at some other ones like that. So step 1, get one of the variables alone, solve one of the equations for one of the variables, and it looks like I'll call this equation A and equation B. So equation A is already solved for y, so I'm going to replace the y in the other equation with 6x minus 9. So I'm going to copy down 2x minus 6, big set of parentheses, because you're going to fill in that y with a 6x minus 9. So this was step 1 done for me. Step 2 is substitute. Step 3 is solve. So minus 36x plus 54. And then 2x minus 36x is negative 34x. I'll subtract 54. What is negative 48, negative 54? Negative 102, and I divide by 32. Oops, that's not the right one. I divide by 34. So negative 34 divided by. And I get x, not y. X is 3. So this is step 3 to solve. Then step 4, you plug it back in. So I'm going to come back over here and drag this equation down here. Y equals, whoops, let me go in blue here. Y equals 6 times 3 minus 9. That's 18 minus 9. So step 4, plug it back in and find y. And then step 5, write our solution. 3, 9. Now if you want to check it, you can. Just plug 3 in for x. So we already know that 3 times 6 is 18. 18 minus 9 is 9, and that gives us y is 9. Then in the second equation B, we've got 2 times 3 is 6. Minus 6 times 9 is 54. And 6 minus 54, is that negative 48? Sure is. So we can always check our answer by plugging it back into both equations and seeing if it works. All right, here's example 2. Well, this time I don't have one of the equations solved for one of the variables. But I want you to look carefully at the 4 monomials or terms that make up these equations that have variables. So I got 4x, 6y, 2x, and y. Well, which one should I solve for that would be the easiest and take the fewest steps? Well, for the 4x, I'd have to move the 6y and divide by 4. For the 6y, I'd have to move the 4x and divide by 6. And for the 2x, I'd have to move the y and divide by 2. But for the y, all I have to do is move the 2x. So I'm going to look for a variable that has a coefficient of 1. And so there's a winner. I'm going to solve this equation for y. So step 1, I've decided I'm going to solve this equation for y. So I'm simply going to rearrange and make it negative 2x plus 12. I'm just moving the 2x to the other side of the equation. Okay? So let me just clear that up a little bit there for you. So I solve this equation for y by just moving the 2x to the other side. Now that's step 1. Now step 2 is take your other equation, and in place of the y, I'm going to put my big set of parentheses there, right? This is step 2 now, the substitution part. And in place of the y, I'm putting negative 2x plus 12. And then step 3 is to solve. I combine those. And I subtract 72. And I divide by negative 8. And I get 10. So I just solved. That was step 3. Step 4, I'm going to come back up here with my 10 and plug it in right there. Okay, so this becomes step 4. Y equals negative 2 times 10. plus 12. And big finish. My solution is 10, negative 8. Okay. All right. You give one a try there. Stop the video, work it out. When you're finished, turn it back on, see how you did. So I'm going to take this first equation right here, the second equation, excuse me, I'm just going to write that as positive 2y plus 1. Just moving that to the other side because x has a leading coefficient of 1. All right, now I'm going to substitute that in for x this time. So I know what x equals. So this time I'm taking my other equation and replacing x with 2y plus 1. Then I'm going to distribute. And combine 10y, negative 10y and 8y is negative 2y. And I'm going to add 5. I'm going to divide by negative 2. And I get y is negative 5. Now I'm going to come right back up here. X equals 2 times negative 5 plus 1. Okay. How'd you do? You try too. Pause the video when you're finished, or pause the video, turn it back on when you're finished. It looks like they already told me x equals. So I'm ready to take this other equation, 10, and then I know what x is in terms of y. I'm going to plug in y plus 4. And that's the big step right there, and I just distribute. Ten y and 2y make 12y. Subtract 40. Oh, there's negative. And then divide by 12. I come back up to the top right here. Negative 2 plus 4 equals x. So x is 2. Okay. All right. There's an assignment in Delta Math for you.